So after we finished fracturing, let's take a look at what attribute we have. We have a lot of groups. I'm okay with that. Maybe we can delete some of the material groups or so, but let's just keep them here for now. I have these other attributes like density, name, part, and some materials too, and we have all those things. So we can actually go ahead and delete some of the attributes. And the attribute will be the ones on the primitive. I don't like the name and the density we have. I'm going to create my own name using a connectivity node. This connectivity node will give me an attribute called class based on the connectivity of the pieces. So basically for every piece, they will have a unique class number. I'm going to change that to primitive level. Okay. And then after that, I'm going to create a attribute wrangle. And it's also going to be on the primitive level. I'm going to create the name myself. It's going to be equals to sprintf. And I'm going to use piece and %d, a old school way of converting integer number into a string. The integer number I'm going to convert from is the class, so add class. So what this means is going to convert this class into a string because it is now a integer. Convert it into a string and replace that string with this %d. Alright. Now if you look at the results underneath geometry spreadsheet, we should also have a name called piece and a number. It's going to be the same number the class number is. So piece 0, right? Class 000, piece 1, class 1, so on and so forth. We have 7,000 pieces. Okay. Don't know why it's keep getting dark. Anyway. So now after this attribute wrangle, we can go ahead and pack them together. Okay. Now this pack will allow me to pack things together, but now it's only packing with one point. The reason being is because it doesn't know how to pack things together. We're going to tell it to use the name attribute, and now it's going to create exactly 7,000 pieces. So every piece now is packed. Okay. Alright. So after this pack, we can now move on to dot network. I'm going to call this distraction sim. Okay. Now inside of it, I need to create the RBD packed object. Okay. Now this RBD packed object will need to go ahead and read. Actually, I can use that first context geometry because my geometry is actually connected to the first input. Now I'm going to create a rigid body solver and maybe a gravity and connect that to the output. Okay. Let's go back to frame 1. Alright, that's why it's not showing. And let's see if they works. Let's go play the animation. As you can see, it starts to fall down. It's really slow, but it's definitely working. Alright. Now moving back on, let's take a look at the few things here. We have some of the attribute, right? Active, animated, all those things. And also the name, which is actually really good. Now we should have exactly what we want, but if we don't, we can go back and fix it. But for now, let's just say this is okay. We have the distraction simulation now. One thing I do want to do though is that I kinda wanted to lock the bottom part. So before we do the packing after attribute wrangle, I'm going to select a few faces at the bottom. Maybe just a little bit more. Right. For these guys, I kind of want them to hold. Oops. We deselect some of these guys. If it's better, I can maybe just have a little bit more shadowing on the breaking fracturing here underneath attribute wrangle. And that's where I created the shadowing, right? So, oh, actually here on the scatter, I can crank up the density just a bit more to maybe have more there. Or I can maybe do this. I can just go back to the attribute wrangle here. I want a little bit more there. I can maybe add a very small number like 0.1 and run it. That's going to allow me to have a little bit more points scattered on other parts, just a little bit, so they're not like completely solid. Of course, it's going to take some time to do the calculation. Alright, did a few tries. I think the proper number is 0.02. So that's going to give me something to work with at the bottom. Still very big patches, but that's actually what I want. So let's go back to the attribute wrangle. I'm going to go select some of the bottom faces. This is going to give me better ways to selecting things. Now I do want to select by pieces. So here I can change the selection mode to groups or connected geometry. And in the settings, I'm going to use the 3D connectivity here. So that way, when I grab, I'm basically grabbing pieces. Okay. So I'm gonna turn off the colorize, so it's easier to see. Cool. So let's say this is what I want to reserve, and I'm gonna group this guy. And for this group, I can call it active, deactive. Okay. Now after that, let me create a attribute wrangle again. And this guy will be again applied on the primitive level. I'm going to tell it to say if at group deactivate, then I at active will be equals to 0, else it's going to be 1. Okay. So this way, I'm basically defining where I want it to be simulated and where I don't. Just to visualize that, I also create a CD equals to 0 for the deactivated one. Now you can see the bottom ones are the ones that are deactivated. Just checking, so comment that. Okay, now moving down from this attribute wrangle, let's take a look at this pack. Now you can see this pack doesn't really have that attribute I just created. So I have to tell it to transfer that attribute. So active, the new attribute, let's transfer it over. It's now on the primitive level, which is still not ideal. I want it to be actually on the point level. So here I'm gonna create a attribute promote. Alright, now this guy is gonna promote the attribute from the primitive active attribute to the point. So now I do have it on the point level now. Okay. Now one more thing I do notice is that I also don't have that name attribute I have earlier. My name attribute from the primitive, right? So I'm going to do that here too, transfer the name also, and also promote it to the point level. So that way I'm using the name I created for the pieces for the simulation. Cool. Now I should be able to see that it's going to hold on those pieces I deactivated. Let's take a look. Now you can see the top ones are now collapsing and the bottom ones are really holding, because that's what I told you to do, what I told the simulation to do. The reason it's able to recognize active attribute is because it's a known attribute right here. We saw that earlier even before we do that, right? This active attribute. Okay. Alright. So that's gonna be the setup for the packaging. We have basically tell it the bottom to reserve the bottom ones, not really simulate that, and also we packed it, we promote the attribute, the name and active attribute, we transfer the attribute here. Just make sure that you do those things, otherwise it will not use the proper attribute that you use that we defined earlier. So okay, let's stop this tutorial now. In the next one, we're gonna go ahead and try to maybe do the constraint network. Okay, see you next time.